Hey folks, welcome back to another video. Today we're looking at question 667, beautiful arrangements 2. To understand the solution for this problem, we need to look at examples. So let's get started. When you're given n, the maximum k value that you can have is n minus 1. Right? So for example, if you have n is equal to 5, the maximum number of distinct numbers that you can get as differences between those numbers is 4. And the way you can do that is by alternating the numbers. And when I say that, I mean you have two series. You have 1, 2, and 3 where you're incrementing them. And you have something that decrements that starts with n. So you have 5 and 4. So this way, when you're incrementing and decrementing, you get the maximum number of differences, which is n minus 1. But what if k is not equal to n minus 1? You need, and what would be the trick there? The trick there would be to alternate it and stop alternating and just keep incrementing the left value as soon as we know that we have satisfied k. So that's the entire meat of the solution. So it's not too hard once you understand how you're actually approaching it. So let's jump right into the solution. The first thing that you want to do is you want to initiate the result that you will be returning. And then you'll have the left integer that starts with 1. You have the right integer that starts with n that you will keep alternating between. And then you'll have a for loop. So for int I equals 0, I less than n, and you increment I. And how will you know how to alternate? The way we'll be doing that is by using the value of k and checking if it is odd or even. If it is odd, if it is even, you can say result of I equals L plus plus. If not, you could also alternate it. You could say if it is odd, just decrement R and add it, otherwise, and vice versa. But we could do this as well, anything based on your preference. And once that is done, you want to make sure that you decrement k. But there's one thing, one check that you need to do. Only if k is greater than 1, you need to keep decrementing it. If not, you will keep k stable. Awesome. So once that is done, you know you've filled up all of the array. You just have to return it in the end. So awesome. So let's compile this and see how this looks. Right, the first test case looks okay. Everything else looks okay as well. Awesome. Let's talk about the space and the time complexity. The time complexity of the entire solution is O of n. Since you are using the for loop and iterating through all of the indices in the result. And then the space complexity is O of n as well, since you are initializing in a new array that you will be returning. Awesome. So that's the solution for this problem. If you have any questions, please let me know in the comments below. And please don't forget to subscribe. I really appreciate that. See you all in the next video. Peace.